Assalamu alaikum guys, again. Today we'll solve your quiz 6 that you had last week on Monday. The question was that acetylene C2H2 is burned with 10% excess air. You were asked two things: first, to find the balanced chemical equation, and to calculate the air-fuel ratio. So to start with, any burning chemical reaction, you have fuel C2H2, which is specified from the question, plus air O2 3.76 nitrogen into, this is the chemical composition of air, okay, and that will always result in CO2 plus H2O plus O2 in this case, because it is mentioned that we have excess air, plus N2. Okay. Plus N2. Now, how to find these numbers? Here there should be factors. How to find them? First, here we start with 1.1 air theoretical. This 1.1 air theoretical, it came from that 1 will completely burn plus the 0.1 that is excess. And as I mentioned earlier, the air is always composed of O2, oxygen, and 3.76 nitrogen due to its composition. And these are always the outputs. We just add this one in case of excess air. If it was complete combustion, no need for this one. Okay, so we start by balancing CO2. CO2 here, we see that there is 2 carbon. So here it should be 2. Then we move to the H2O. H, there is 2 H. Another color. Okay. H, there is 2 H. So here it will be 1 because H is 2 here. So 1 plus O2, the excess air, and this was given from the question that it is 0.1. So it will be here 0.1. And for N2, it will be 3.76 multiplied by the factor of the air theoretical. So it will be 1.1 air theoretical multiplied by 3.76. Okay, here till now we balanced half of the equation because still we don't know the air theoretical factor. Okay, how to find the air theoretical factor? We can find it by balancing the oxygen in our equation. So here, starting from the left side, you can see in the reactants we have 1.1 O2, air theoretical O2. So this is the factor of the oxygen in the reactants. This will equal how many O2s here in this one? We have 2 O2 plus how many O2 here? Here, just take note that this one is 1. So this number will take half of it because we have 1 O, so it is half O2. Okay, but no need to write O2 here, just for illustration. Plus the 0.1 air theoretical. Here this is air theoretical. Okay, now solving this equation, taking this to the other side, 1.1 minus 0.1, so we'll be left with air theoretical will be equal to 2.5. Now the equation that we wrote, we will just write it again. We go down. Here. Now we'll go again, write the full equation, C2, make it different color, Okay, C2 H2 plus 1.1 multiplied by A theoretical, which is 2.5, will give us 2.75. O2 plus 3.76 into, this will equal to 2 CO2 plus H2O plus 0.1 multiplied by 2.5, it will be 0.25. O2 plus 1.1 multiplied by 25 multiplied by 3.76, this will be 10.34 N2. Now this is for the first half. This is how we balance the equation. So the first part of the question is done. Till here, is there any question? Or it's all clear for balancing the equation? Yeah, okay, good. Okay, great. So this was the first part of the question. Now for the second part, you were asked to calculate the AF ratio. Now, just a reminder that the AF ratio is defined as the mass of the air over the mass of the fuel. But here, since we are dealing with a chemical formula or a chemical equation, there's no masses. So instead, we can use the number of moles and the molar mass to identify the AF. This can be written as Nm of the air over Nm of the carbon plus Nm of the hydrogen. Okay, why carbon and hydrogen here? Because down we are calculating the mass of our fuel, and our fuel will be basically carbon and hydrogen, because if we went back to the question up here, you can see that acetylene C2H2, this one, it will be burning. Okay, now here what we are left with is just substitution. You just have to check the values from the chemical equation, and of course we should know that the molar mass of the air is equal to 29. This is 29 kilogram per kilomole. And for the carbon, molar mass of the carbon is 12, and the molar mass of the hydrogen 2 here, H2 is 2, and all in kilogram per kilomole. So Nm, the mass of the air is we have 2.75, the factor. We multiplied by 1 mole here, 1 mole from this one, and 3.76 from the nitrogen. So total you'll have 4, and this O will be multiplied by 29, which is the molar mass of the air. And this here, no, it's not 4, it's 4.76. Okay, multiplied by 4.76 multiplied by 29. Okay, again, just to explain where we got each number. Okay, the 2.75 is from the balanced equation. The 4.76 is from the air, because air consists of 1 mole, you can say 1 mole of O2 plus 3.76 mole of N2. So adding these two numbers, 4.76. So this number will always be fixed when calculating the AF ratio. But here this factor depends on the chemical, the balanced chemical equation. And this 29 here, this is the molar mass, and this one will be always fixed for air. Then now we can go down to the second part, the mass of the carbon. We here can see that we have 2 carbon, so 2 multiplied by 12, the molar mass of the carbon, plus here 2, but this is 2H2, so it's basically just 1 multiplied by 2 for the H2. Plugging all these numbers in the calculator, you will get AF of 14.6. So this was your last quiz 6 on Monday. First you have to calculate the balanced equation, and then calculate the AF ratio. We covered both questions. It was incomplete combustion because there was excess air, and to balance the complete combustion it's just the same, but here it will be like no need for this 1.18 theoretical because it will be complete, it will be just one. Okay, so any questions about this, about the quiz, this one or the previous one, the psychometric chart? Yeah, okay. If everything is clear, that's all that I wanted to cover for this tutorial. I just want to solve the quiz with you, and I want to check if you have any question regarding the previous quizzes, 5 or 6. Okay, no questions, that's good. I'll stop the recording here.